Hello, my name is Roger Bolton. We're standing outside of the Winery Brewery Food Science teaching program here at the University of California at Davis. Behind me are a series of buildings which have been built to be the LEED Platinum standard. And these are buildings which are both solar on-site capture, rainwater on-site capture, and have a number of features which are important in sustainable design. I hope you'll come with me as we can tour through these buildings and understand their features. Behind me are 14 2,000 litre fermenters that have been built for teaching primarily, but also large-scale experimentation. The important feature of these tanks is not only their automation and their ability to be self-cleaning and what we call clean in place, but it's also they've been designed so that we capture the cleaning solutions that allows us to reuse them. And we do that by not only washing the tank, but capturing the solution before it hits the floor so that it doesn't become grey water. And now it's still processed water. Now we can take it, refilter it, and return most of it tomorrow to wash the next tank. In the future, we believe that most wineries will be cleaning tanks in this way. And we're trying to demonstrate that both for industry to learn from, but also to our students, of how to use water multiple times instead of just once. This is one of the 152 research fermenters that we have as part of our research program. It has a number of unique features. One is the outside of the fermenter doesn't have a lot of fittings, deliberately, so that it's very easy to turn this upside down and clean it. The ease of cleaning becomes an important feature in the ability to use less water in the cleaning process. The second feature is these are only warmed up by hot water and cooled down by cold water. So we switch from water system to water system to be able to heat and cool. And then the third feature of them is the heating and cooling is performed in such a way that the jacket water is only flushed and replenished if it becomes warm. So unlike normal designs where people would flow coolant through the jacket continuously until the temperature of the wine drops, this particular system pulses jacket water, holds it, waits for it to warm up, and then actually flushes it out again. And in that way makes most heat gain for the water, for the cooling system, and doesn't put a lot of cold water back in to a cooling system that occupies a lot of volume that actually makes it run less efficiently. And so it's a small feature, but when you've got 150 fermenters, it becomes a big feature. These fermenters also measure the density automatically, report it and display it, but send it wirelessly. And together the 152 represent probably the largest wireless network in the world of fermentation. All of the carbon dioxide that's released from the fermentation is captured. And through manifolds throughout the building, the carbon dioxide is removed from the building, not dispersed into the air. What that means is we don't have to bring in outside air to displace the carbon dioxide. What that means is we don't have to bring in warm air that makes the building warm, but then we'd have to have an air conditioning system to cool the building down. So it's worker safety, it has the ability to capture it for future sequestration, but it also has to do with building energy loads that are significant, but what apparently is a small feature. Behind me is the Jess S. Jackson Sustainable Winery building. And this is a building separate from the winery, but a very important integral part of the entire idea. The building is a very good example of a passive building, high insulation, very low energy, built for the climate here in Davis. But it's also a building which will house the number of different technologies that will allow us to use water multiple times and to capture extra energy to power up batteries to operate the winery at nighttime, and to build systems that will capture and sequester the carbon dioxide from our fermentations. This building is heated and cooled by air intake in early morning hours in the summer to cool the building, and warm afternoon air in the winter to warm the building. The air system brings the air to each particular room and brings the coldest air to the floor, and each of the alternate windows opens and pushes the warmest air out. And so we're doing a layered vertical displacement airflow pattern in this building. The building also has natural light from solar tubes, and it also has tubes within the floor that can be used in the off-season of the harvest for warming the building in winter or cooling the building in summer. One of the features of these buildings is that it actually operates on two water systems. The first water system is captured from the winery roof, ground surface capture, and put into the tanks behind me. And this is grey water, and this is water which represents a year's water supply for the toilets and landscape of this building complex. In so doing, no external water is used in these applications in these buildings. The building tanks were designed to be integrated with respect to the architecture, the size and the angles of the roof itself. Rather than have one big building, one big tank, one big ugly tank, what we wanted was something that was actually more compatible, that gave more of a barn, farm-like structure, and yet they were functionally water tanks. And that's what these are. They have a polyethylene plastic lining, so the water is not in contact with the metal, and the solutions coming in are filtered to roughly 50 micron and then ozonated to kill all organisms. But to avoid chlorine, to avoid other chemistries, and to store a year's rainwater for the functioning of the building. I hope you can see that a building like this, which is using captured rainwater and captured energy, is the kind of building we need to build more of in the future, and is an example for others to learn from. While we are fortunate to have the opportunity to work in environments like this, we hope that this building and the systems that it demonstrates is the kind of demonstration site for the world to learn from, and we encourage you to come and visit.